Well, now we'll do the worksheet for 11B. So if you can get that out and follow me. The first question is, what is the first principle of perspective? And the answer is, when you read through those, C, and it's all lines are parallel, that are parallel in the real scene, and perpendicular to the canvas must intersect at a principal vanishing point of the painting. Number 2, which letter is an example of reflective symmetry? And the answer is D, K is. And if you, here's a K, and if we flip it over, we get, and we can make that like that. If we flip it over, we get another K. Reflective symmetry. Which regular polygon can be used to make a tiling with a single polygon? And the answer is A, and that's a hexagon. And the by the way, it's not a dodecahedron. I had to look that up. That's a solid with 5 pentagonal faces on page, you can see that on page 561. But to find the measure of each interior angle of a polygon, regular polygon, the formula is this: n minus 2 times 180 divided by n. And so a hexagon has 6 sides, so n equals 6. So 6 minus 2 is 4 times 180 divided by 6, and 6 goes into 180 30 times, and that equals 4 times 30 is 120. And those are the degrees in a each interior angle of a regular hexagon. And by the way, when you add 3 times 120 is 360. They have to, the sum of the angles has to add up to 360, otherwise there'd be overlap or a gap when you try and put them together. So when making a tiling using only regular hexagons, A, the tiles fill all the space with no overlaps, no gaps. So number 5, it says draw 2 cubes, one with perspective and one without. Well, I've done that, and here they are. This cube does not have perspective, this one does. And you can see it tapers a little. For question 6, it says draw an object with rotation symmetry. Well, I've drawn a couple of them. One's the letter O, and you can keep rotating that, and it always remains the same shape. Here's a diamond, and you can, or a square, and you can rotate that every 90 degrees, and you get the same shape. So now let's turn this over, see what we have. And this question is, identify the symmetries of the following figure. Well, it's got rotational symmetry. We can rotate it 90 degrees, 180 degrees, we get the same figure. It also has reflective symmetry. We can fold it over a horizontal line or over a vertical line. It also has, we could also fold it over diagonal lines, and so we have reflective symmetry. So the answer is A. It has reflective symmetries that can be reflected across a vertical line and so on. So for number 8, we've got this figure, and it has, and the pattern continues in both directions. So it turns out it's B. It has translational symmetry. We can slide it one way or the other and it never changes. And also we can reflect it about a horizontal line that's between the maxes and mins, between the peaks. Now, finally, let's do 9, and it says form a tiling from the figure. Okay, I've drawn that tiling. Here it is, from the figure of a right triangle. Also for 10, they want a tiling from that figure, and I've drawn one, and there it is. And that covers this section, 11.